document number, and then you go there, take note of the document number, and then you go to the racks or shelves or the cupboards where the particular documents are kept. You go there, and if you take out that your number you have noted down, that number document you take out and you try to really make use of it. This is what normally goes on in your indexing system, or what you really call it as information storage and retrieval system like. Okay, now I said, what is the file you are going to search for? I am going to search for the index file. So in index file, what really happens? So, this file, index file, what you really maintain. So normally in general also, every file, it is a single unit, and then it will have some kind of a computer, handled, information will be there. File will be a single unit. Say, for example, I have a, say, let me say my article is there in one particular file. On library automation, I wrote an article that is in the library. My file is library automation like. So in that I have quite a good number of the number of pages, so number of sentences, etc., subheadings, some chapters, etc., are all there in that like. So like that, what happens? Every file, at least in our ISIR systems, every file contains some records. Records means entries. So for every document, you prepare a record, isn't it? So like that, we have, let me say, we have 10,000 documents are there. We have prepared 10,000 records for them. Okay. Now, in those records, what we really do is we will really try to really give the particular record. If it is your catalog record, what happens? You try to identify, provide so many access points like author-wise, title-wise, subject-wise, keywords-wise, these, that, all those things you really provide. Here, what normally you really provide is, now in an index file, normally what happens? If a document is dealing with 2, 3, 4 concept words are there, maybe you are creating 2, 3, 4 keyword records you are maintaining there. So every file, say my index file is a file for all the documents of 10,000 documents. Now you have really prepared some kind of index file, okay, and that will be representing the documents, and they are nothing but every file will have some kind of records. Your catalog has so many entries, isn't it? So many records are there. Similarly, index file also will have some records. Coming back to the records. Now, in each record, what you really write? Author name, title of the document, maybe the journal name, and then year of publication and the publisher's name. These, that, all those things you write. These are all nothing but these are the metadata information. These are the information that will really help us to retrieve or take out the, identify and take out the documents like. So every file will have some records, like catalog records. Every record will have some, some fields of information. Author field, title field, subject field, edition field, publishers field, like that. You have got some fields. So every file will have some records, and every record will have some fields. So a few fields put together a record. A record represents a particular document, and several documents are there. You prepare several records, and several records put together, you really call it as a file. This is what you have to always understand. Now, in our, when I really want to say file organization, what is the file organization? In the file, what will be there? Only records are there. How the records are arranged in the file is your file organization. Okay, that's what we are now really going to talk about. Okay, now these first most important thing what you have to understand is, every file will have some records. Catalog is a file. Catalog contains records or entries or whatever you really call, isn't it? Maybe main entry, maybe add entry, whatever it may be. So a catalog is a file. That file contains some records. Every record will have some fields, author field, title field, etc., etc. That's what exactly you want to really understand. Now, the next important aspect is Now, file organization. How you are organizing files? I mean to say that how the records contained in a file are arranged is equal to the file arrangement. File arrangement means the arrangement of the records in a file is a file arrangement. Okay, there are at least basically some 2 or 3 important methods of file organization are there. Number one is linear lists. The first important aspect, what we really call it as the linear list. What do you mean by linear list? Linear means in one sequence, one after other, in one line. A, B, C, D, E, F, 1, 2, 3, 4, 5, 6, like that. That's a kind of order. So first book is first record, second book is second record, third book is third record, 20th book is 20th record. So one after other in a sequence, you are really arranging them in some kind of sequence, that's some kind of order. Order is that maybe A, B, C, D, E, maybe 1, 2, 3, 4, 5, maybe the order. So first prepared file is first number, second prepared file record is second number, third prepared record is third number. There are 40,000 records are there, all are put 1 to 40,000 records are there. That 1 to 40,000 records, so totally you call it as a file, one file. Why? Because all these records, every file contains some records. Understood? So every record contains some fields. Okay, like in one record, some information is there. Like maybe the first one you said call number, author, title, publisher, edition, publisher, etc., etc. You don't. Same is the way all the records in the file, they are homogeneous in nature. They will be having the same kind of information only. So in a database or in a kind of information storage system, now the file will be having records, but all the records are homogeneous. All of them are alike. All are same. First field is this, second field is this, third field is this. In record 1, the fields, the sequence is same. In record 2 also same. In record number 40,000 record also the same record. Same fields and the same order also will be really maintained. That's what we really call them as homogeneous records are there. So now we are talking about file arrangement. File arrangement is nothing but arrangement of the records in the file. Okay, arrangement of the records. The first method, what we really call it as linear lists. Okay, linear listing of the records in the file. That's what we can really say. Linear means in one line, one after other. Okay, first one, second one, third one, how they are really been added to the file there. So we have 20 records are there now. Another new book has come, 21st book. You prepared a record, its number will be 21 only. That will really go after 20. When you are filing also in the same way. Okay, so then what really happens is, now these are nothing but, this is the simplistic structure of the files. They are unordered collection of the records. There is no order in that. Only order is sequence. First one first comes, second one second, third one third. So that's how you are putting it. Like there is no other order except that. As and when the files are you are adding, you see I have 10 records are there. The 11th record has come now. The 11th record will be after 10th record only. One more record has come, that will be 12th. It will be after 11th only. So there is no other order except that. So they will be in one line, in one sequence only. The sequence is only maybe there's some logical sequence, first come, first come. So like that you really maintain. And when new items are added, always they will be appended at the end. New records have come, new will be at the end only, not in the beginning or not in the middle. You are not inserting them in between. You are not interpolating them, the records in between or in the beginning. So the last come, last will be first come, first only. That is the sequence, what you really maintain it like. Okay. And the existing sequence of the records is not altered when you are adding some new record. So some 21 record number 21 has come, where you are going to put after 20 only. 20 records are already there. 21 has come, that will be at the end only. So all the new records are added at the end only. As and when new things are coming, they are simply added like. That's what exactly, as far as linear lists are really concerned. But now what will really happen is, say for example, I have 40,000 records in my index file. Now somebody has come and asked for one particular record. When he is searching, what really happens is the search will begin the record number 1. So you said, I want a book written by Jones. Okay, I want a book on Jones. So now what happens? So the sequence is first book first, second book second, etc. The records are there. So it takes, the computer takes that Jones name and will be really comparing the first. You will go to the first record and will see whether this Jones is there first. No, it's not there. Go to second record, Jones is there, not there. Then go to third record, fourth record. Like that, it will be searching in a sequentially, one after other, etc., etc. Goes to all these 40,000 records. Here it has to search, then come out wherever the Jones is really matching with the record. Then that particular, it will stop. It will searching process and give you that information about this Jones book is here, something like that. That information will really come to you. So what you understand in this, when the records are only small in number, searching them in a sequentially, in a linear order, in a one after other, when you really keep on searching, probably it is not really that difficult. I mean to say that it won't take much time. But when the records are many, what really happens? It takes more time. That's one very important aspect you have to understand. In a linear file, all the records are arranged in a sequence. The sequence is only first come first, next, last come last. Like that it is going on. So a particular document, when you really want it, you have to go from first onwards, search. Is this the book what is asked for? No. Then second you go to, is the book asked for? No. Is the book what user is asking? No. So you have to search all these 40,000 records. How much time it takes, either for you manually or it is by the computer? It takes a lot of time, very inconvenient, like, isn't it? Therefore, this what we really call is this linear lists. This sequential arrangement, like 1, 2, 3, 4, like that, or etc. This is not really been preferred. Okay, this sequence is not really been that important, like that, because it takes more time. When you have got documents, maybe 10, 20, 30, 100 documents are probably you'll be able to see it, find. But when there are running into thousands and thousands and lakhs of the documents are there, these linear lists are not really going to help you there. So then what really happened is, there is one new concept has come for the linear list, like that's what we really call it as the second one. What we call it is clustered files. Like instead of linear sequence files, you are really going to have the clustered files. Like what normally happens is, say for example, now you really group, you make some grouping, like of all the files. There are 40,000 are there. So what normal you said is, say for example, most of your users are searching an author name. Imagine for some time. Okay, now what really do is, now you put in one particular, with the first file, what you really do is you put only all the authors names beginning with A. The second one, what you will do, all authors books beginning with B and C and something like it. You will have all the, for on all the alphabets, you will have one, the kind of separate clustered files are there. So if somebody has come asking that I want a book written by Johnson. Okay. Now what happens? So you have to go to the, you leave our A, B, C, D, etc. files, you leave and go to J file. JS place clustered file, and there you search whether Johnson books are there in that or not. So this is one other alternative method within the linear list. Like I will tell you one good example for this linear list is that imagine for a while. I think I will just tell you. I am having my own document running into 250 pages book is of my book is there in the computer. Somebody wanted that, that used to be of that, somebody wanted that, the one at page number 120. I want that particular page. It is something very interesting for me. I want that page to be printed. So what you do is you give the print command to the our own printer, isn't it? You have a printer in your place. Your file is there in the computer. Now I want only 120 page number only. Only one page, 120 page I really want. Or I want 120 page to 125. All those 5 pages are required for me. So what I do is I go to the computer and give an instruction, print pages that knows row I will give you from 120 to hyphen 125, isn't it? 120 to 125, and then you give instruction to the computer printer. Then printer immediately will not print. Why? You know what happens? Printer first will go that 120, where is 120 page in the file? It will go and search. Go first, will go to number 1, 2, 3, 4, 5, 6, 100, 120. So when it goes to 120, that 120 number and then that page number of the document, those both are matching. Then it starts printing. Like meanwhile, it takes maybe about 50 seconds or 1 minute time it will take. Because it is going to what page 1, no, it's not that, page 2, not that, page 3, not that. So like that, it goes to all the pages. When that 120 number is found, then it starts printing the page and gives you like. So this is what exactly the linear order files, when you want to retrieve. Okay, now it takes more time. So therefore what we said is we maintain some clustered file, some groups we maintained. Now instead of combining all of them, the files with A alphabet, the author files with the B alphabet, C alphabet, one files. So like that, these are all clustered files, not single file. You are maintaining within the file. This grouping is really been done. So what really happens when you really want to search for information? Clustered file is I want Johnson book. You can go straight away to J and then search instead of going to A, B, C, D, like that. You don't need to go 1, 2, 3, 4, 5. You don't need to go. I want Johnson. So I go to Johnson file only. I mean the J file. J is a clustered file. All the authors' names which are beginning with, let me say, the author called J, Johnson, Jones, Johnson, Judith, this, that, all those things, all of them are there in J only. Go there and search it. So what really happens? That the file containing the author's records with J alphabet will be small in number. Instead of when you want to say A to Z, all of them are combined together, means it's really going to take more time. That's what normally happens as well. Therefore, what they really said in your so author Jones, J, Ash, etc., etc. So in the beginning, all of them are like that, because in the first record is Jones, it has come first. Then of course second record has come Ash has come second, Ash author. Third is Brown is author. Third record is Brown is number 3. Then Adams is number 4, fourth file. Then Smith book is number 5. It is 5. Arranging like that. Instead, what really we are going to do is Ash and Adam are at one place. You put all the files in Ash and Adam at one place only. Say for example, Smith and Scott, etc., or S, you put somewhere, B at one place, J at one place. So like that, if you can really club what really happens, at least to some extent, you will be able to save the time of the searching. Like, what really happens is, why I am talking about searching time is the effectiveness of an indexing file or indexing system is also measured in terms of how much time it is really taking. If it is taking too much of time to find information from your index file, it's not a good index. It's not a quality index. No, it's not substandard. It's not good. So you should really immediately should be able to give you the answer, but it should not take more time. So that is also one of them. Then that's what exactly. Now what in the second one, what I said was ordered sequential files. In this, what happens? The name of the author may be the main criteria. You put all the alphabeted numbers at one place, etc., and you use them as keywords and search like that. That's what exactly the one way what we can really say ordered sequential files like. So to locate a specific information, the search starts at the beginning of the ordered sequential files and works towards the end item by item. So like that, you go to that single file and then we'll be really searching from the beginning to the end. Whenever you really find, you really get it. Like in this also, what they really said, and they have given an example here. So what the mechanism you really want is, now there are A, B, C, D, E, F, G files are there. Okay, you have got records with the A, B, C, D, E, F, G. Now there are 7 records are there. So what really happens? The another way out for easy searching is, now what happens? The first search will go to the middle of the point. Middle of the point maybe the D. So it will go there, and then what you wanted, I really wanted a book. Now something like let me say now Cox is the author. I really want it, like, okay. So Cox book I really want. Now then what happens? So that is C. So C, I want C record. It will go to the file, will go to first to the middle point D. Then you will try to see whether this C is will be down D or up the D. So above D it will be there, or below D it will be there. So down D, what really D, E, F, G, etc. will be the down. After, if you really proceed beyond D, it will be E, F, G. If you really come back towards that, then C, B, A, etc. will be there. So naturally the computer will assess that. No, okay, when A, B, C, D files are, E, F, G files are there. Now when you go to the middle point D, then it will search. You want the record number C is required for me. So C will be down D or above D. It will be above D. And then it will naturally search on the above D only. Again, I think in that again it will go to the midpoint. Naturally, it will really get that midpoint C immediately in the next or third kind of attempts, like. So like that, this is how your indexing will be really done in linear list, or what you really call is ordered sequential files. These are both are them nothing but they are the sequential listing of the files, ordered listing of the files only. Okay. Then there is also another better method is there. What really happens is now instead of simply putting giving a record number 1, 2, 3, 4, 5, etc., and putting them as per the numbers, etc., and searching as per the numbers, or putting the files alphabet A, alphabet C, etc., etc., and searching right from the beginning to till the end till you get a particular record, etc. This is one crude way of doing it, like very raw method of doing searching for information, like. So what you really normally do is the third method, the very important method is called indexed files, like. Okay, what you normally do in this is you don't arrange them according to serial number wise, you don't arrange them according to the author wise, but what you really do is you are really going to try to index the files as per the subject content contained in them. Say for example, we have in your library, there is one example is given. Now what really happens is, now you are indexing the files according to the subject words, keywords only. Now, in the library, say for example, you have got there are 2 books are there, book number 1 and book number 3, with the subject called computers. There is another book is called information is there. It is also there in book number 1, book number 2, book number 4. I think information concept is there in that. So retrieval is there in book number 1, book number 2, book number 4, and book number 5, etc. Why I am telling this is, now information retrieval system. So information management system. So like that, no, a book is dealing with both information and management, etc., isn't it? So like that, what really happens? So first you try to analyze your document and what key concepts are there in that. You try to identify those key concepts. On each and every concept, the document number you write it. Document number is action number, you write it, like. You are not going to use call number, you are not going to use author name. What you are going to do is, the document is there, document deals so on so concepts, so on so subjects, like subject terms, you take out those subject cards, and each and every card you write that number, like I told you in the beginning. So in the index file, what normally happens is one index card may represent multiple books. Okay, at the same time, okay, one book will have multiple cards also, because the book is dealing with 3 concepts. So interlibrary lending in public libraries, the book is that, title is that. So public libraries, okay, one concept, interlibrary lending, another concept. At least 2-3 concepts are there. So you have got those 2 cards. On those 2-3 cards, the same book number will be posted in that. That's what you got to understand. So like that, what really happens, people will really go, I want some books on information retrieval. So information 1 card, retrieve another card. You take out those 2 cards and try to see what are the common numbers. The common numbers containing books are the books which are commonly having these two concepts in that particular book. That's how what you really do is you index them. We call them as inverted files. Actually, we are not arranging according to serial number wise. We are not putting that kind of index file according to author wise. We are not putting title wise. No. What concepts are there? Identify the concepts. On each and every, if the book is having 4 concepts, you take out those 4 concept cards and then you write this particular book number, that book number. Then of course, what really happens in the same cards, you must have already entered some other books also. So this is what normally goes on. As far as index files are really very easy, and this is time saving, and that will really help the process of searching and finding out information, etc. Like this is supposed to be the best method of indexing. Indexing is inverted files. Indexed files are inverted files, and what we have used here, index files only. So that's what the third way. So what really happens? What is the file arrangement in an indexing system, ISIR system? There can be linear lists, all line one by one arrangement. There can be clustered or grouped files. These two are same only. Then third one is what we can really say is indexed files. The files are indexed, and so that people will really try to combine those concepts and try to really identify them. Like this. Then the nature of files. How the nature of files is? Now, what really happened? There are 2 types of the nature of files will be there. That is what the records. When I am talking about file is nothing but records only we are talking. Because whenever I say file is nothing but every file contains several records. The arrangement of records in a file is the file arrangement. That's what you have to understand. So in that our records can be fixed length records, or records can be flexible length records. The record length can be fixed and the record length can be flexible, not fixed. That is what normally we call not fixed is variable length fields. We call 2 words like variable. The length of the fields vary. They differ from one record to other record. So normally what I said, the data in a fixed field records, what happens? Author field, we say first field is author field. Author field will be given, say for example, 15 characters. So you can write only author name up to a maximum of 15 lines, so 15 letters only. Title, I said 25 records, characters. Okay. For writing title normally will be big now. Therefore, I said 25 records, isn't it? Say, for example, year of publication, I said four characters, like imagine like that. So what really happens? Author name, Ram is there. You need only 3 characters. Okay. Say, for example, Addepalli Appala Narasimha Raju is there. How many characters you really need? Maybe 30-40 characters you need it. Isn't it? So what really happens, if it is a fixed field, now you have to, when I say 15 characters, beyond 15 characters, it won't take that much only. That's the maximum. You have to adjust it like this. Then second field is title. You said Into the Heart of the Mind, the American State of Artificial Intelligence. Another book is there, Accountancy. I think it's easy. You can write it. But your 25 character space, it cannot take more than that. So that what really happens in a fixed length, what you call fixed length records, the fields in a record are same in all the records. And then the first field, say for example, author, second field is title, third field is edition, and etc. etc. Same system will be there in all the records, but the each field length, how many number of characters can be recorded in the that particular field is already fixed. So what really happens? So you have given 15 characters for author, but my author name is only 3 or 4. Raju is the only name of the author. But what you said, you have left 15 characters for that particular field author. Like the remaining 10 character space, they are empty, blank. You have to keep them blank, unutilized. That means the file will unnecessarily have the overhead occupancy. No data, but the fields are occupied as blank spaces. Then after the 16th, the character position will be the title you are writing. So like that, this is a kind of situation in a fixed length field. It is difficult, the file unnecessarily will be occupied with blank spaces, overhead, the spaces. Then of course, when a lengthy title is there or a lengthy author name is there, you can't write it. That's what these kind of drawbacks will be there as far as your fixed length, the records are concerned. Each record in the document file occupies the same space, and the fields within a record also follow the same sequence. So every field you fixed. Let me say there are some fields like year of publication. Probably those 4 characters is sufficient for us. But name of the author, title of the book, etc., you can't do it. Second important thing is the drawback in this fixed length, the field, records is, say for example, for a book, there are 3 authors are there. You have to write all the 3 authors' names. The author is a repeatable field. There can be multiple authors. Therefore, you call it as a repeatable. No, there is no scope in a fixed length fields or records. Even though there are 3 authors are there, 2 authors are there, only you can write the first author. That too also less than 15 characters only. So this is how there are some kind of drawbacks are there in the fixed length fields, and therefore people normally prefer what you really call it as the varied length fields are most preferred. Like now, say for example, in some areas, when you are creating a kind of database, essentially the DBMS systems or RDBMS systems, what normally happens is, I think this we talked in the last class. So the field, the space, each field, how many characters it has to occupy is already fixed. I think you have to only limit that. Say for example, let me say for author you have given only 8 characters. Let me say my name is Sudarshan Rao Sargu, isn't it? So you can't write Sudarshan Rao Sargu everything, because you can say only probably up to Sudarshan RA. That's all. Even O also it cannot accommodate. It will not accept. Then you have to go to next field, write other things. My title you have to write. So these kind of problems always will be there with the fixed length fields. Therefore, in order to overcome that, now what we said is we are really going to have the repeatable fields that will allow each field should be, should have any, there is no fixed length for that. No, it can be a smaller one, bigger one, etc., etc. Anything it can accommodate. That blank spaces unnecessarily leaving them out will not really happen in these what we can really call the variable length fields. Like okay, then we will so each variable length record may contain 1 or more fields, and the field lengths may vary from one record to other record. So in the fixed length fields, every record position is clear. You can understand. Say for example, a particular character. If you really want to say first, every record will have only 40 characters, 39 characters. So second record naturally begins at 40th character. Okay. Then of course, third record naturally begins at let me say 60th character position. So like that, you can always fix when a new record is really starting, when a new field is starting. All these things can be calculatable. You can really count them and say, okay, this is what really happens. But in very variable length fields, now because we have given bigger option, any length can be there for author. You can have more number of authors in that. Any length you can use. If the author name is only short, the remaining will not, next character will go to the next field. So there is not, there's no restriction on that. Like So this ISO 2709 standard, I think it will also help us, this kind of support it will really do. And then of course, instead of identifying the fields by author field, title field, each field is really been designated as 100 is author, 245 is title, 300 is something like that. You really try to use it, edition, etc., etc. That kind of numbering coding also will be there, and these will really help you, as each record is a different size, and as it is not possible to calculate the position of the specific record. So what is the length of the record? You can't say. Some records may be small, some records may be big. Every record varies from other record. Every field data, say for example, author field for one record it is 25 characters, in another record it is only 5 characters. So title can be only 10 characters in one place, 140 characters in another place. So these kind of things are really possible. So that what really happens, the actual information, exact information about each and every document can be recorded when it is a variable length record. Okay, and the variable field length is really been admitted. I think you can write all those things. This is what the fixed and variable length records. The difference between those two things, what we can really say is fixed length fields, they're all fixed. Author is 10 characters, something like that. In a variable length field, the length, if anything, any length you can really use, 10, 20, 2, 3, anything you can really use. Fixed length records, the sequence of fields is fixed also. First is author, second is title, third is edition, etc. Now here it is not that. In a field sequence may vary from record to record. Say for example, in one record there is no edition, only author title is there. I think the edition will not be there. That compulsory field is not required in this. Fields with no value are filled with blank spaces in the, as I told you in the beginning, in the fixed length field, but that there is no question of blank spaces. So all the space will be really occupied. Now there will be overhead of disk space. So unnecessarily, when in a fixed length, what really happens is disk is unnecessarily occupied with blank spaces. That problem will not be there in this variable length fields. Single header includes field names, their type, size, and sequence. Here, general header includes all the details. That's what exactly the difference between them. So the position of a record and the fields in a record can be calculated. So if you can really say each record is 19 characters, 20th character in the beginning of the second record, that can be understandable. So in each record, if the author is 10, so when 20th beginning up to 30 will be author, when 31st will be title only. So like that you can always identify. That's not possible in the variable length, records line. So this is what normally, as far as what is the difference between fixed length fields and variable length fields. Now coming back to there are other kind of files to be called as flat files. Is one concept is there, and you can really to define a single record type for the entire system. Now the software will really help us in what is this flat file. You just try to understand what is a flat file like. Okay. Now flat file systems adopt the variable length record concept, and they are best suited for bibliographic description, like our library catalogs, like our marked records. Okay, so this is what what happens. The data included in these is static in nature. It is not going to change. The concept of flat file is one stored data. Say for example, a book data we entered into the catalog record. Is it going to change anytime? No, it won't change. The same author will be same, title will be same, edition will be there. For that particular document, it will be the same. So there is not going to change. The data will not change in that. The data is cumulative. Because what happens, you are really adding the data to one file, other one record, etc., etc. New records are always added to the file, and decisions are minimal. Okay, sorry, our deletions are minimal. You normally don't delete a file. You simply will keeping on adding some more documents. Each record is of variable length. That's what exactly the idea of flat files like. And there are repeatable fields also possible in that. Okay, like that. Data related to a single item is to be kept at one place only. Okay, in one record only, in a single record only. Okay, mostly narrative or text-oriented data is really been stored in these flat files like. The system is not transaction-oriented. Like, banking service, I have an account. Okay, now today I have added 4,000 rupees into my account, and tomorrow I am taking 8,000 from my account, say for example, or 2,000 I am taking from that. So when I really added 4,000, my account data will naturally change. The data is modifying. When I have again, say for example, as of now, I have got 8,000 are there in my account. Today I am adding 4,000 rupees. So what is my account data? Data is changing. Now it will be 8 plus 4, 12,000 will be at my credit. Now tomorrow what I said is I have really taken 2,000 rupees back. Now what is the amount that will be left out in my account? It's only 10,000. So the data is varying. Data is really dynamic here. But in the bibliographic records and catalog records, the data is permanent. Normally don't change. That's what we really want to say about it. Okay, so single record type only, and because all the fields are there in that. Okay, no author, title, edition, ISBN number, this, that, all those, something like that. Each record should be a comprehensive record, and that means every information about that particular document should really go into. So like that, this is what normally happens as far as your, the files are, what files, flat files are really concerned. They are all, any amount of information can be recorded in that. And what you really repeatable fields information can also be really added there. And so like that, there will be one single record for all, comprehensive for the entire document. This is possible only for ISA system. Then coming back to when you really look into your mark record, you have for each and every record, you have a record structure, maybe label, then header or something like that, the first part, 24 characters, then the directory of all the fields, then of course field actual data, etc. So the data, then the directory, then the header or leader, and then the second component is the directory, third is actually data lake. This is how you really arrange the data in this records. Okay, so that's what normally happens. Then of course, when you are talking about data, especially just take an example of banking services, you have an account. Now you have some information is there about you, personal information, maybe financial transaction information. So we always want to really use data. You need to have the data privacy and data security. The information about my account, the money that I really have in my account, I don't want to share with others. Like, it cannot be, we have to maintain it secretly. It should be secured. Like, nobody can really hijack my data and then take my money into somebody, transfer that into somebody's account. Like, so that's what exactly, you are talking about cyber attacks and then threats like. Hello. Japan. So this is what, as far as for whenever we really talk about the data, we need to have we need to maintain the backup of the data. We need to suppose what really happens in our library, we are making issues and returns, automation is going on. So that issues records, who has taken which book, it's already be there, only computer the transactions are there. Say for example, for some reason there is a kind of hacking or some problem has come, the whole data is lost. So that's not possible. Therefore, what really happens, at regular intervals, you are really keeping on maintaining the backup data, so that that the data loss problem can be overcome. Like, data security is also really important for us. Like, so these things always will be going. The privacy of the data and all those are very, very important. Okay, now coming back to the next kind of thing is, now what you can really say is how you really search for your information and what are the search methods you normally do it like. Now the searching methods are many times what really happens. So sometimes because when I'm talking about indexing file, when I'm talking about indexing file means you are really been indexing the documents only on the subject keywords. Okay, now when the subject keywords is the indexing is really going on, searching is most preferred. Searching is what we can really say is, that is what exactly called as Boolean logic. Boolean search method. What are the Boolean operators? I'm sure you must be knowing it. And, or not, and or not. These are the three Boolean operators we call. So we use these like I want something like nutrition and food. Okay, I want only diet and nutrition, but not food. Okay, so like that I can say I want the library automation, but not library information retrieval. So like that, you can use the not word and word, or I want food or nutrition or diet. I want external relations, international relations or foreign relations. So you can really, when you are, constructing your own search query, when you are constructing a search query, you can use these three operators: and, or, not. And means what is that is, and means the intersection of that. Okay, or means both. A plus B is or. Okay, I want foreign relations, or I want this or this, etc. And when I say and means what happens, so that is the intersection of both the things. Like, so this is what R means. I don't want that concept. So this is what, how these are the three important role operators will be really used in indexing system. And while doing so, what normally we really do is, now in this searching system, that's what normally our database searching also we use in a kind of sets, like set 1, set 2, set 3. Set 3 normally could be set 1 and 2, something like that. We try to mix these searching and then try to really get what information we really want it. Like, I have some examples in your book also. Say for example, now when you are searching a kind of information from a database, set 1 is first searching is on information services. You made a search. Second search, you really made an information systems. That's second set 2. Third is set 1 or set 2 you said. That is the third search. Like, I think information services or information systems is both are required for me. That means you combine both things and then you really get it. So then set 4 is in Asia. Set 5 is, say for example, in Europe. And then you said, I think that's how you can really. Yes.
Sir, page name is 195.
190, yeah, there only 190, 198, and so on. So this is what normally happens. So this is how we are really going to make a search is our Boolean search. What we are going to use and or not operators. Now our searching will be on set style. So first you make a search. Let me say I want something on information services, set 1. Okay, set 2, library services, set 2. And then set 3, both A and B. That's could be your. So you can really retrieve all of them. So like that, you will really be making searches on different sets, and whatever you really want, you can eliminate and you can really get it. Like, this is how the Boolean search is one of the important search. And there are also many other searches are there. There is what you can really say is a proximity search. So one concept that is nearer to another concept. Another concept is I want anything published that is greater than symbol, and then 2001. Anything published after 2001 only I really want it. That's what exactly that year wise also you can say. Then wildcard search are there. That means what I said is I use COMP. Now it can give you computerization, computerized, okay, like that, all other words that are really been, ending with that COMP, all are really been taken to consideration. Wildcard search, okay, number 1. At the same time, proximity search, nearness. Okay, I want heart and attack. 2 words are nearby. I just want that information. Like, so like that, we will be really searching for information like that, and then we will really try to get. There are many methods are there of all those things. Boolean logic operator, using Boolean operators like and or not is going to be one of the important methods which we will be really using in our information retrieval from the index database indexing. So that's what exactly. So you now come to know about it, how the files or records are arranged in the file. Then what is the arrangement, like maybe the you can say sequential or the linear list. then of course that's not supporting. You are really gone to the clustered files, grouping them maybe alphabetically, all authors one place, etc., etc. Then of course the next one is the inverted files or the indexed files. You really index the concept and then really try to use it. Like, then of course you really have seen what is the kind of the records or the files having the fixed length fields and variable length field. Variable length field means the field length is varying, like, okay. Just 1 second. Just 1 second. I think I can show you on the screen how these Boolean operators can work if the time is there at the end of the session. Okay. So I will try to explain to you by drawing these things. Are you listening now? Anything is there?
Yes, sir.
That's good. So because time is not available much, I just want to go to the next unit. Next unit is evaluation of ISR systems and methodologies. Okay. So the next aspect is now you know that in our indexing files, actual documents and resources will be at one place, and we try to look into each and every document, try to identify what are the key concepts, key subject matter that is really discussed in that, and for them you are really using index terms, and then they are being filed there. People will really go and search there. While searching, I think the searching methods I really gave you, that like Boolean logic, wildcard search, proximity search, and there are some more methods are also there. I think people will really, of all those things, Boolean logic, Boolean search. Boolean search means is a person Boolean. He has really used this kind of and or not operators. Using those things, I want say something. What I say is, I want education, and I want training, not children. Okay, so I don't want children education, but what I want is education and training. So I want both these two concepts together should be there, but not for children. That means might be for elders you are talking about. So like that, when you are constructing or creating a search query using these and or not, I want let me say or means in our context plus symbol. Okay, and means that multiplication symbol, intersection of both the concepts, like so not is negative minus symbol. So that's a not is minus symbol, or is plus symbol, and is intersection multiplication symbol, like. Okay, so this is what how these search will really help us. Now I want let me say international relations or foreign relations, and not of India. I want something else, isn't it? So I want something like let me say food or nutrition, but not diets. Okay, food and nutrition, something from diet. Diet, maybe somebody is a patient, I think the restricted food is called a diet. There is a small difference is there between diet, food, and nutrition. Nutrition element is something different, food is something different, but diet is again another slightly different one. If it is food or no, nutrition is okay for me, but not diet. I'm not talking about diets of the people in like patients, etc., etc. That I don't want. I want only this. I want this, not that. We are using NOT. I want this and either this or this. So in order to use or, I think what exactly is multiplication parameter, this or that. So like that, and or not are the three important operators we really use in searching information. One of the best methods of searching information using these Boolean operators, like. So then next, what we really do is the evaluation of ISR systems, so information retrieval, etc. We really want to look into that. It's a new 11th chapter, unit number 11. Your page number, somebody will be asking 200 pages or 200 onwards. Okay. Now, evaluation. Why we really do evaluation? Evaluation is only to assess the performance of a system, like whether it is working well or not, what problems are involved in that, etc. You try to know about it. If it is not really properly working, where it is not properly working, then of course you also then try to really rectify that and then try to improve the performance of the system, like. So evaluation is first of all to examine the performance of the system as we have really planned. We have planned for a system to work like this. Is it working in the same way or not? you have to really do it. A periodical evaluation will be really done. So I have really prepared one indexing system I have developed, whether indexing system is working well or not, whether I am able to really give the proper index terms to the document, etc. or not, whether my indexing system is helping my user to comfortably search and retrieve, or it's taking more time, etc. So there are so many issues are there. So you try to really look into the indexing system, and then whether it is really working well or not, working appropriately or not. If you really find that it is not working well, you have to make some modifications, alterations to that, so that it will really work in a better way. That's the idea. So evaluation is only done. So the objective is to improve the performance of a system. We normally go for evaluation. Now, what you do in evaluation is you measure the performance, and it can be performance. First of all, what you really do is you test the the system, whether it's working well or not, for its effectiveness. Then the second one is you try to identify or diagnose what are the the problems or the failures in the system. Then third one, what you really do is you try to give some therapeutic things. There are three stages are there. One is testing, second one is diagnosing. You have tested the system, then you found there are some problems are there. So where the problem is there, say for example, when you go to diagnosis, whether it is a problem in eyes, whether it's a problem in ears, or something like you try to really identify where the problem lies, and then the problem is identified. Therefore, what you take some treatment, medicine, therapy, maybe something like that. So this is what there are three things are there in your evaluation. It includes testing, diagnosis of the problem. Third one is what you can really say is therapeutic study. That means trying to do treatment. Therapeutic study is treatment. So test, diagnose, and treatment. These are the three components will be there in evaluation. Like any other thing is also can be applied for the information retrieval systems also. Okay. So there are two kinds of things are there: macro evaluation and micro evaluation. Macro means bigger. Okay, micro means bigger, means in a larger way, in a bigger way. So you try to really make out, oh, the system is working well or not working well, or something is wrong with this. You really come out within the macro level. Micro level, what happens, where it has gone wrong, whether it is in indexing terms, not suitable terms, not in the searching or in a keyword formulation, or maybe in content analysis, where the problem has really come up, that you are really identifying. That is the micro level. The evaluation can have two phases. One is macro, the bigger level, whether problem is there or no problem. The problem is there, which area the problem is coming up. So like that, these two things will be really doing. So the evaluation can be done at any stage of an information system, maybe in the conceptual or experimental stage. Also evaluation can be done. Maybe at a prototype, means you are really initially you prepared a kind of plan, work is there also you can do it. Or once it has really, the system has already been prepared, planned, and put to execution, going on, working going on, then also you can really do the what you can really say, the evaluation line. So evaluation is performance evaluation. Evaluation is always trying to find out if it is not really working properly or not. You will diagnose, you will identify, you will test, then you will try to make some adjustments, so some refinements, so that it will really go in a better way. So the stages in the evaluation system is, first, when you really do the evaluation, what are the different stages are there? Establishing the scope and purpose of the program, deciding what to evaluate. Then evaluate yourself, decide your scope. I want to evaluate this indexing system. I want to evaluate this kind of things. I want to evaluate the indexing language. I want to evaluate, say, for example, let me say the search, the methods. I want to evaluate the search interface. The computer and man are interacting with the system, there I really want to evaluate, is it really working or not. So you have to define first that. Then design the evaluation. How you really want to evaluate? Some methodology. You try to really come out. Then you really conduct a study and then collect the data about them. So first define your problem, Then what you do, you try to identify what methodology you really wanted to use to check and find out the problem in that. Then, you collect the data, analyze and interpret the results. And also the failure or success, whether the data with that you say whether the system is really working well or it's a failures, etc. Identifying the causes for the poor performance, why it is happening. Okay, then of course, then you should suggest some remedial measures to improve it. Then making a system, you have to release some modifications, then evaluating the modified system again. So this is what, it's a routine cyclic one, like. So testing the system, identifying the problem, giving some treatment for that, therapeutic measures, suggesting some modifications. Then again, you really modify the system. Then you conduct the system, run the system for some time. Again, you really test it, whether it is really coming up well or not. And that's how it goes. It's a cyclic one. Testing, diagnosis, therapeutic. I think this is a what you'll do, continuous thing. Some modifications you make, implement it. Then whether going well or not, again you really make a study. Then if something is going wrong, again you really try to give some remedial measures. Then that's what exactly is a treatment, therapeutic. Then again you implement it. Then you again test it. So this is exactly a cyclic one. It goes on as far as your, the indexing evaluation system is really concerned. Like, okay. So in evaluation also, what there are 3 concepts are there. One is what you get system effectiveness evaluation, whether the entire indexing system is working effectively or not. You really, because up to the expectation. Effectiveness means we have some parameters are there to call an indexing system effective now. So recall and precision and recall are one of the 2 important features are there. Whether whenever you really want, whatever you really want, are you really able to retrieve it or not? Whatever you are retrieving, is it you are getting with the precision or not? Accuracy is not there or not? So when I really want, I will tell you, explain. So the precision and recall are going to be some of the 2 important features. Then whether it is very convenient for the people to search, or it is taking more time on creating inconvenience for the people, those who are searching the system, like whether it's more time consuming, like, well, there are some other factors are also there. So like that, system effectiveness evaluation is one thing. Other effectiveness criteria is cost effectiveness, like what cost effective means. Suppose, say for example, I have spent 10,000 rupees on this. Am I getting at least 10,000 rupees worth benefit from that or not? So that is what we really look at. So that's what is called cost effectiveness. I spent this much of cost, this much of amount. Is it worth for that cost? That's what exactly our idea is. The third one is slightly nearer to that. What we can really call is cost benefit analysis. Cost benefit means normally it's a business concept. Like now we really, in our management terminology, what we really look at is returns on investment. Like I invested 1,000 rupees. I'm expecting 1,500 rupees back from that, isn't it? ROI, return on investment. How much I should get back? I have invested 1,000 rupees. And I'm expecting 1,500 or 2,000 rupees. I'm expecting from that, because I spent 1,000 rupees invested on that. I should really get 2,000 rupees. That's what exactly returns on investment. My investment is 1,000. I should get more than that. That's what exactly ROI, return on investment. That's what you really call is cost benefit analysis. Benefit, I am benefiting. Though I spent 1,000 rupees, I should get more than that, isn't it? So at least I should get up to the value of 1,000 is cost, what you say, cost effectiveness analysis. Like for that cost, it is okay, sufficient. Now I am looking from cost benefit analysis. That means to get more benefit out of that. So these are the 2-3 kinds of methods are there as far as the what you really say is the evaluation, how people really look at is cost effectiveness, system effectiveness, how system is working effectively or not. Then in the system effectiveness, the second component, cost effectiveness. We have spent this much of money. Is it really worth for that? At least that much we are getting or not? That is cost effectiveness. The other one is cost benefit effectiveness. That means how much benefit I got. I spent 1,000, but I should really get 1,000, 2,000 rupees extra over that. That's what exactly the outlook like. Then coming back to the next one is evaluation of system effectiveness. I mean, here we are going to talk about evaluation of the indexing system, ISIR system effectiveness, how it will be there. There are 4 or 5 parameters are there. Now the effectiveness evaluation concentrates on the user requirements. Okay, so user is key. Now what user wants, is he really getting from that or not? User wants information quickly, is he really getting it or not? User want the information in this way, is it really getting it or not? So this is what user is more important as far as evaluating an indexing system also, or ISS system. So coverage is one feature, that's what we really say. So coverage means if I have in my library only small number of documents are there, naturally I will not be able to provide a better service with a small literature. Yes or no? The coverage, whether the coverage of information is comprehensive or only limited, it also a matter of factor. Then second one is recall, third one is precision, fourth one is system response time. When I really make a search on indexing file, how much time it is taking? It is reasonably good time, in few seconds or 1 minute it's giving, or it's taking hours and half an hour. No, we won't like it like. User effort involved in that, that's what exactly user interface the computer, how much effort the user is going, that's what exactly we say. It must be user friendly system, it must be comfortable, user friendly system should be there. So then form of output, now whether what you really want, are you really able to get or not? These are some of the criteria we will try to look into it. Like the coverage means, I just now told you, whether you have got literature comprehensively or only limited way. That's very, very important. If your coverage or collection of the resources are very small, you can't expect a better output, ruled out. That's a kind of problem. So system effectiveness itself is there only. I have only small number of documents are there. Naturally, I will not be able to do justice for my users like. Then the type of documents, whether in your particular indexing system, are you also articles, journal articles, reports, chapters in a particular document? Are you doing it, or only you are doing only indexing for the bigger documents? That's also a matter of that. Then the period of coverage, whether you have got the information right from 1900 onwards, or only you have literature only from 1900 to 1950 information is only there, but I really want to do the current information is not there. Isn't it? The currency is not there. So that's what important like. So these are the other factor like. So time taken to really find information also very important aspects. So these are all in the coverage. One aspect like. So coverage of information, whether it is the current information or retrospective old information is there in that. Whether the exhaustive information is there or only limited information is there. So these are all the coverage information. So if the coverage of information is good, naturally your retrieval also will be really good. Then recall, like there is a formula is there for recall. Recall means what? Now in the database or in the storage, some items are there. Whenever I want, I should be able to really get the page without much time failure. Like so, recall there is a formula is given here. Like so, the formula is the number of relevant documents retrieved by the system. Okay. When you really make a search query on the indexing file, the number of documents you have really got it, divided by what is that? The total number of relevant documents contained in the system. Okay, the total number of documents relevant to your question. Okay, you are asking something like biotechnology. On biotechnology, let me say that there are 100 documents are there. But what happened when you really make a search, you are only able to retrieve only 80 documents. 20 documents are not retrieved. There are some problems with the system. So your retrieval efficiency is only 80%. Like so, the number of relevant documents against your query is retrieved divided by the total number of relevant documents available in the system into 100. That will really give you the percentage of what you really call recall. So the documents are there in the system. When you went on to really retrieve them, take them out, only out of 100 relevant documents available in the system, you got only 80. So the formula is the total number of relevant document retrieved against your query divided by the total number of relevant documents available in the indexing system. అందులో ఎన్ని వచ్చినాయి multiplied by 100. That gives you the percentage of what you call recall. Recall is calling back. They are there in the system, but you are unable to really get them. This always happens. All the relevant documents you will not be able to retrieve. Okay. Then next one is what you can really say is precision. Precision means how accurately you are able to retrieve it. Retrieving the documents, recall is one aspect. Precision, like now, what happens when I really make a search on that? I got, let me say, 80 documents. I got it. Out of 80 documents, only 60 are relevant for me. Follow me now. In the earlier case, there were 100 documents relevant to my work are there. When I search it, I got only 80. In the other case, what really happens is, now when I retrieved 80 documents, okay, but of all the 80 documents, 80 are not required, relevant for me. Unnecessary documents also I retrieved. Some required documents I did not get in the first case. Some unnecessary documents also I got it in the second case. You got me in a point. So the precision is that the number of relevant document retrieved by your indexing system divided by the total number of documents retrieved by system. So what really happens when you retrieve it? You retrieved, let me say, for example, 120 documents. After 120 documents, 80 documents are only relevant. The remaining 40 are not relevant for my requirement. So this is what exactly you really call precision. I want books on this only that particular subject. No additional things are required. So this will tell you that when you go and make a search in indexing files, some required files you will not really get all the required files. At the same time, whatever you really got it, all of them are not really needed for you. That means some unnecessary also you really get. Some unnecessary you are going to get. Some required things also you are missing, not getting that. So this is what exactly normally what happens as far as your precision is concerned. Like precision means how accurately I retrieved 80 documents only. Are the 80 are really important for me? No, only out of 80, 40 are important, 50 are important, 60 are important. That shows your precision ratio is also poor. So here there is one formula was also there. What is the formula? Is that the precision of the system, that means how accurately you are retrieving. Then of course the recall, okay, how more number of documents you are, useful documents you are retrieving. The precision and recall, they are never, directly proportional to one another like this. So you can't expect 100% recall and 100% precision also. So precision and recall are inversely proportional to one another. If you get more precision, the recall is less. If you get the recall more, the precision is less. So two things will really hang like this. If one is more, the second one is less. This precision is more, recall is low. If the recall is more, precision is low. So this is what really happens. Therefore, what say the precision and recall are inversely proportional to one another. If one goes up, the other one goes down. Okay, this is what happens, both the recall and pressure. But ideal situation, what we really expect is the indexing system should have 100% recall, index system should have 100% precision. So these two values can never be achievable. So if one is more, the other one naturally will be less. That's what normally happens as far as index system is concerned. Like the third factor in evaluation is that the user friendliness of the system. That's what we say, user effort. How much effort you are really putting up to get your required information. How much time you have to really take. Like that's what exactly the response time. When you really make a search on the index file, whether the computer or the search query is really been responding to you very well or not. So this is another important aspect. Then output also. When you really want to say the output of the information retrieval system is whether is it really the output what you are really going to get, is it really comfortable or convenient for you to make use of it, etc. The output may be brief bibliograph citation sometimes only citations you get, only with the keywords you really get it, only abstract you get, only sometimes you get complete document also you really get. What you want, are you really getting it or not, the output? That is another question. Like so the assessing the recall and pressure, that's no, I just not told you. Now what really happens is in every time, now when the retrieved documents, in that some will be relevant and some are not relevant, whatever you retrieve. And when in index system, now the documents what you really retrieve is there will be A hits are relevant for us and B noise will be there irrelevant. So when you retrieve, there are both A plus B. Noise, unnecessary documents will be there. Useful documents also will be there. A plus B. A is hits required documents. B is noise, unnecessary documents. So A plus B will be retrieved when you are retrieve it like. Now, what you have not retrieved is sometimes some documents you miss retrieving them. See, they are required for you, but you miss them. The system will not help you. Then, of course, what not retrieved is those are actually not required. Therefore, they are correctly rejected. So, because they are unnecessary, they are rejected is one aspect. There some of them are really required, but then still it is not showing to you, not really showing to you. So C is documents relevant for me, but they are missing from retrieval. Then there are D is there. They are actually, yes, I don't want them. Therefore, it really, stopped giving to me. So that is D. So when you do not, what you don't retrieve is some of the required material, that is C, and some of the unnecessary requirement C, D you retrieve it like. So the what is the relevant is for you actually A plus C is required for you. Some of them are missing, it is not showing to you. Some of them it is retrieving. Now what not required is B plus D. B is naturally noise, unnecessary things, and D is actually correct. These two should not really get it like. So in the total collection, what will be there? A plus B plus C plus D will be there in that. So A is really required things, B is nice. Both are coming when you retrieve it. What not coming is some of the important C, they are missing, they are important, they are not coming. Some of them are justifiably, genuinely, they don't want it. They are also not coming. So in our index file, naturally, when you went on to retrieve it, A plus B, whenever you search and get it, some relevant, some irrelevant, you really get it. Okay, and then what you did not retrieve or you can't retrieve is some of them are relevant, but I did not retrieve. Some of them are not necessary, therefore they are not retrieved. So not required is also not required retrieved, and required also is not required, C plus D. So that's what exactly the index file contains. A plus B plus C plus D. These four kinds of things will be there as far as your index file is really concerned. Then the next one is what you can really say is this concept will be really always many times will be asked for your examination also. Failure analysis. Failure analysis means what happens? It's a diagnosis of of your indexing system. So where the system has really gone wrong. The failure analysis is a diagnostic system, but the most important part. So in a failure analysis, one concept normally will be asked for you in the short notes like you are diagnosing where the system has failed, where the problem is really been coming up. You really try to involve. It's a careful examination of the documents in the collection, the indexing policy and procedures, the indexing language, the original request posed to system by the user. What kind of question you really asked? The interpretation of the request by the searcher. Okay, and the original, then of course the search strategy used to complete these things. All these things are matter. When you, if in an indexing system, when you really don't get what you really expect, that's nothing but it's a system failure. So we are trying to assess failure analysis. Means what? Where the failures are occurring in the system. That's what you are trying to really look into it. Like that's what we call failure analysis. Like say for example, I am a user coming to you as a librarian. I want on so and so information. I really give my search. I want information on so and so. Then you search for information and give to user. User is not happy. That means he is not. There is a failure in the problem. Where the problem lies, whether the problem lies in converting the user requirement into searchable words, first question. Okay, whether the user subject is really appropriately indexed when though the documents are there? Were they really properly indexed? The indexed in terms were really been reflecting the same thing what I know the documents are really mentioning. When you really make a search, whether your search strategy, search query is properly maintained. So like that, there are many issues. Indexing system, indexing language, okay, the request made by the user, which is really converted to search query, etc. Are they really going well? So these are all the issues normally we make analysis in order to say where the failure has taken place. So the failure analysis is conducted a large number of searches, and then of course now it indicates the principal problem areas in system where the problem lies. Indexing terminology, at the stage of indexing, at the stage of filing the records, at the stage of searching the information, at the stage of really, constructing the search query. So like that, it goes on. There are multiple areas. You have to always try to look into them. And the principal problem areas, the areas that require attention and modification. So ultimately, what you are really going to do with failure analysis? Now you already identify, you diagnose that, this is a problem is occurring here. Then you try to make some modifications to that. You make to some kind of refinements to that. So with the refinements, what really happens is you will be really able to again, put the system into back in a better way. So this is what exactly, there are other possible sources where this failure analysis can really happen. User expectations will be something on your system. They expect so many things and they come to you, and then you are unable to really give to them that. So there you say, for example, they came and asked for some information. You did not search a proper database. Now they have come and asked you some information. You searched it maybe in Project Muse or Taylor and Francis database users. No, actually you should have gone to EBSCO database. You have gone to a different database. Therefore, you are not getting information. Okay. Then of course, when a user submitting a search request, probably he is unable to express correctly what he really wants. This happens many times. So the failure analysis reasons are many. So user unable to express what he exactly wants. But ultimately, when you give information, he is not happy with that. Okay. So that is what exactly the kind of things like. Then of course, when user makes a request to me as a librarian, I could not understand properly what he was asking for. Maybe he is expressing correctly, but I could not understand it like, okay. Then of course, I am unable to really search properly the database. Therefore, I could not get correct results like. So like that, there are many things are there. Okay. So where the system is really going wrong, and I'm unable to really get the information what the people. That's what exactly failure analysis. Where the failures have really taken place in the indexing system, we have to really make things like that. Okay. So this is what precisely I told you already, the evaluation of cost analysis and also evaluation of cost effectiveness. Cost effectiveness is nothing but, now the how effective is your system, okay, and the costs involved in achieving the level, etc. The evaluation of cost effectiveness. So I spent this much of money, but I'm really getting the commensurate to the cost I really paid. I really spent on that is really the idea, like, okay. So the maximum value after spending some kind of money on the system, am I really going to get it or not? That's what exactly what we call cost effectiveness. I spent some cost, some money on that. I invest something on that. On the investment, at least to that cost, am I really getting the benefit of that? Is not. So maintaining the present performance level while reducing the costs of the operating system, like. So can you also really reduce the cost of the system? That's what we are looking at. We are not in terms of looking about how much money I am getting out of it. So can we reduce any costs or expenditure? That's a kind of look as far as effectiveness is concerned. Okay. And can we really also improve the performance level? So how to improve the performance level given the same, the thing is really going on here. Now, can we really reduce the cost what we are really incurring on the system? This is what normally we call cost effectiveness. When I said cost benefit analysis, I told you it's an ROI concept. Returns on investment, ROI. It's a business concept. I spent 100 rupees. I'm expecting 200 back from that. So in the earlier case, I am looking for with the same cost. I am trying to see for a better performance, better system okay. So that is what exactly cost, analysis, effectiveness. Now this is cost benefit analysis. For that much of cost, how much I am really going to, get back all those things. So comparing the cost of the service with the cost of obtaining the same by other means. So I spent this much of money. If I can really get the same service from outside agencies, will I be really getting the, okay, or which is cheaper for me? So that way you are really always looking it. Then, okay, estimating the time gained or the increase in the productivity of the. So with this, what normally happens, if you have a system in your place, depending on the information service from other agency, other center, they are not readily available to you. So you have to forego your time, isn't it? So you are spending money, that's okay. But maybe you are spending little money, less money. But you may have to wait for longer time because the system is not with you. So like that, these are all the issues which we will be really looking into. What we call the evaluation system effectiveness criteria, like cost effectiveness, cost benefit, and then effectiveness of the system, okay. So all then failure analysis also we really discussed. Then also I think this is what we have done. Now I think if you have got anything to check with me, you can ask me. I will, if you want, I will show you a little later about how this Boolean operators will really work. Any questions from your side? Any questions from you?
No, sir.
No question. No question. You don't have any question now? So actually, I just want to explain to you this Boolean logic. Okay, 1 second. Boolean logic, where should I really go to take some kind of Boolean logic. Are you able to see now?
Yes, sir.
Okay. So we have 3 operators are there. There are 3 operators in this. One is and. This is multiplication. Two is first and. 2 is and or. This is what you say is addition. This is plus. This is multiplication. Okay. And is multiplication, or is plus. Okay. Then number 3rd operator is what you say is NOT. This is deletion or minus. We don't want this. Or minus. Symbol is minus. So these 3 operators are really being used when we are really trying to make a search for the things like and or not. These are the 3 operators, and or not. Okay, we call them as Boolean logic or Boolean operators. There are 3 operators are there. 3 are 1 are not, etc. How this will really work, I will tell you. Just show you how. Clear. Okay, let me say this is a word, This is B word. Now, A word, let us say, this is food. B is nutrition. Okay. Now I want food or nutrition. My question is food or nutrition. Anything is okay for me. So then what happens? So both these things will really come. Honestly, this part is really talking about food and nutrition, where these two things are joining. This is food and nutrition, actually. So this is food, this is nutrition, this is food and nutrition. This is food. This circle is food. This circle is nutrition. The document dealing with food are this. The document dealing with nutrition are this circle. When I say food or nutrition, the intersection of both is really going to be the food or nutrition. This part, this is, see, this part is inclusive of both. In a particular document, when the concept food, about the nutrition, both are there, this area. This is what exactly we really want. We can really use it like, say for example, I want okay, food, I want food, I want food, not nutrition. Not nutrition. I want food, not nutrition. That means what happens? I want only this much. The remaining is not required. In this part, both food and nutrition is there. In this part, nutrition is there. I want only food. That means only this I should really get it. So this much I should not get. In this part is both inclusive of food and nutrition, and B is only nutrition. I don't want nutrition, so therefore I won't get it. So that looks the same, but I don't want it like. Say for example, what this is what normally happens. This is and or not is the Boolean operator. So how we really use in searching for information. I want let me say I want library automation, but not in India. So I don't want Indian story. I don't want. Why? I want only outside world information. So not you can use there. Library automation. Okay, the library automation. So library, but not. I don't want anything from India. So India minus India. I want library automation not from only not from other language other than English. Like so, like that you can really always use this Boolean logic. This is how they really work like. Okay, clear, right? This is how these things will be really working like. And this is one of the important method of searching for information. So like that, something like that. What happens? First is information services in India, but not something like from UK. And then you can really eliminate that. Like I want information. So like that, what really happens? What information you really want? You can really always formulate your own questions and then get the information. Like that's what. Any questions you have got, you please ask me. I'll tell you. Any questions? Any questions from you? Sir, your class is what are your teaching skills? One cannot use your class. Thank you. Somebody. Any questions? I am just looking for. Any questions? Please.
Question, important question and answer questions లాంటివి ఏమైనా చెప్తారా సార్? నోట్ చేసుకుంటాం.
ఇప్పుడు today's questions, what I said is now what are the file organization methods? One question is there. Okay, And second thing is like flat files, they mean normally short notes
మళ్ళీ
question.
ఒకసారి చెప్పరా ఫస్ట్ ది ఫైల్ ఆర్గనైజ్
File organization. File organization nothing but record organization. Okay. Then
Nothing
somebody
but-
may also ask you, explain the what is a flat file. Explain how the fixed length records are with the variable length records like. Okay. Before that, one important aspect what I really want to tell from here is Boolean logic is also one important aspect in this. You can always have it. From the next unit, you can always look for the evaluation of indexing systems. The criteria for evaluation of indexing systems, like the coverage of the system, precision and recall, isn't it? So like that, these are all the precision, recall, the the user friendliness of the system, the time spent on the system, time taken for answering the question. So like that, there are all some of the criteria I have really told. So user friendliness or effort, system response time, then your output, coverage and currency. Coverage, comprehensive coverage, or do you have current literature with you is always a kind of matter like. Okay. Then somebody sometimes will ask you failure analysis. Sometimes people may also ask you explain what is this precision and recall values also. So precision means how accurately you are retrieving information. Okay. Recall is how large number of items you are really retrieving against your question. Okay. These are all the issues can really come up in these 2 units. Any more questions?
సార్ ఎగ్జామ్స్ ఎప్పటి వరకు ఉండొచ్చు సార్? ఇంకో 3 months వరకు ఉంటుందా? 2 months?
అని ఎవరు మీ కిరణ్ అండ్ రాజా గౌడ్ ఆర్ మేడం నాకు తెలియదు. నేను అంటే డైరెక్ట్ గా అంటే యూనివర్సిటీతో టచ్ లో లేను నేను, అందుకే తెలియదు నాకు.
ఓకే సార్.
మళ్ళీ నేను ఎవరు కనుక్కోవాలి కదా, మీరు అడగండి డైరెక్ట్ గా సార్.
ఓకే సార్.
రైట్. చదువుకోండి మంచిగా, మీరు బాగానే చదువుకోండి. కాకపోతే ఎక్కువ మంది రావట్లేదు, అదే ప్రాబ్లం. ఇంకా ఎనీథింగ్ మోర్? If nothing, I think we will stop now. And we will see. Tomorrow also I have a class, isn't it?
Yes, sir.
Yes, sir.
Tomorrow we will meet. Get prepared and come. Okay, na?
Okay, sir. Thank you, sir.
Right. Thank you. Right.
Sir, సార్ వాళ్ళు ఉన్నారు ఎవరైనా? రాజ్ సార్ వాళ్ళు?
ఎవరమ్మా?
ఇంకా వేరే సార్ వాళ్ళు, సార్ అడ్మిన్ సార్ వాళ్ళు.
I don't know whether you can try whether Anil, that Kiran or Raja.
కిరణ్, వీళ్ళిద్దరిట్లో ఎవరైనా ఒకరు. అయితే ఏంటంటే మాకు సార్ అది మెటీరియల్, అది సారీ ప్రాక్టికల్ ఎగ్జామ్ టైం టేబుల్ హైదరాబాద్ వాళ్ళే వచ్చాయి, మరి రాలేదు. ఆ సార్తో ఒకసారి మాట్లాడదామని కాల్ చేస్తే లిఫ్ట్ చేయలేదు సార్ మొన్న చేస్తే.
You make a phone call now after the session is over.
ఓకే, ఒకవేళ ఉంటే ఇప్పుడు లైన్ లో ఉంటే మాట్లాడతారు కదా అని.
I think he is now not there.
గ్రూప్ లో ఎవరు ఉన్నారని.
I don't think he is now available.
Okay, sir.
1, 2, 3, 6. All are in the screen. Nothing, they are not there. Raja Rajeshwari and Enukunda Varalakshmi, Rashid.
Yes.
We are only there. Rahul, but they are not there. Rajita, Sunita, and Bhukhya Swami. And from here, who is there? Somebody is here from Bro.
బ్రో హైదరాబాద్ ఒకటి ఉంది సార్, అదే ఎవరు అంటే లేదు.
You just try, you make a call to that. The name is not there here.
Yes, sir.
Anyway, we will meet tomorrow.
Okay, sir.
Okay, thank you. That's good. I am stopping now here.
Okay, sir.
Thank you.